So you are welcome to my first lesson, and in this first lesson we are going to look at scientific units and measurements. Any calculation you are doing in science, you need these two units, as you can see: basic units and then derived units. Basic units are units in which other units are derived from. You need basic units in order to do any calculation, and the derived units are units which are derived from the basic unit. Another name for the basic unit is also the fundamental unit. Fundamental unit. It means you can't do away with it. So a combination of two or more fundamental or basic units gives you derived units. Now there are 7 basic units. There are 7 basic units. 7. And to remember them, I have a mnemonic for them. I call it Telmalt. T-E-L-M-A-L-T. Telmalt. Now the T. The first T is for temperature. The second letter E is for electric current. Then the next letter L is for luminous intensity. Temperature is looking at the hotness or coldness of a body. Electric current is looking at the flow of charges. And luminous intensity is about looking at light. So we are done with T, we are done with E, we are done with L. So the next one, mass. We are looking at how an object weighs. Then amount of substance. Amount of substance. Then the next letter, L, is for length. Then the next letter, T. These are your basic units. These are your basic units. So we have Telmalt, so T for temperature, E for electric current, L for luminous intensity, M for mass, A for amount of substance, L for length, and then T for time. Now these quantities that I've mentioned have SI units. Now when we talk about SI units, they are the internationally recognized units. Anywhere you go to and you mention these units, they know what you are talking about. So with temperature, you have Kelvin, and the symbol is capital K. With electric current, you have ampere, and the symbol is capital A. Then luminous intensity, you have candela. The symbol is small d, small c, small d. So you maintain them. This capital K, this capital A. For example, with candela, you don't see capital C or capital D. This is it. The next one is mass, kilogram. There is gram as well, but the SI unit is kilogram. And the symbol is small k, small g. And amount of substance. The SI unit is mole, and the symbol is MOL. Then length, meter. Then the symbol is small m. Then time, seconds. The symbol is small s. So these are the basic units. These are the units you can't do without. You need these basic units in order to get derived units. Now, let's look at derived units. These are your derived units. These are some derived units, not all of them. Derived units are more. Now, these are the derived units. We have volume, we have area, we have density, velocity, acceleration, momentum, force, work, and then the next one is power. As you can see, power. So let's start with the first one, volume. I want us to be able to generate the SI units for them, and it's very simple. What you have to do is you have to understand the basic units very well. When you understand them and you apply them here, you don't have to chew the unit of velocity, the unit of momentum. Most students have issues with that. Now let's look at volume. the formula for volume is length multiplied by breadth by height. That's the formula for volume. Now, you have length here. What's the unit for length? Meter, small m, times. Now, we have breadth here. Looking at breadth, which of them in the basic unit is synonymous to breadth? It is still length. So the unit is small m. Then looking at height, length is also synonymous to height. So you have meter cube. Meter times meter times meter. You have meter cube. So this is why the unit for volume is m exponent 3. Area, we said length times breadth, and the formula is meter squared. Now let's look at density. With density also, we have, the density of the unit. The formula for density is mass over volume, or mass on volume. From our basic units, the unit for mass is kilogram. The SI unit for mass is kilogram. And from the derived unit, you can see that the SI unit for volume is meter cube. So our unit for volume density is kilogram per meter cube, or kilogram m minus 3. Now, we have velocity. I want to add another thing, speed. Velocity is displacement over time, and speed is distance over time. The difference is that velocity has a direction, but speed does not have a direction. And they are all distance. Let's just assume distance over time, because they all have the same unit. Now, we have distance here. Looking at the basic units, which of them is synonymous to distance? Okay, I think it is length. So, in length, what's the unit of length? It's meters. So, capital M, small m, over unit for time is seconds, equals. So you have meter per second, or ms minus 1. So with acceleration, we have the formula for acceleration is velocity over time. Velocity on time. Now, the unit of velocity over here is meter per second over s. Why s? Because the unit for time is seconds. So we are going to have meter per second squared, or ms minus 2. Okay, maybe you might be wondering how I came about ms minus 2. So let's just do something over here. We have m over s divided by s. Where do I get this from? I got this from m slash s over s. So this is it. So mathematics tells us that we have multiplication here, 1 over s. So we are going to have m over m times 1 is m, s times s is s squared. So we came up with this. Yes, that's how we came up with that. So let's continue. So we have the next one we have is momentum. Now the formula for momentum is mass times velocity. So by now I believe you are comfortable with how to generate the unit. Mass times velocity equals, the unit for mass is kilogram. Kilogram times velocity is meter per second, so m slash s. So it's going to be kg m slash s. Now this is multiplying this, so I don't need to write kg slash m slash s. Since you are multiplying, this is multiplying this, so it's kg m slash s. So that's the unit for momentum. There is no need cramming these units because you know them. So force is mass times acceleration due to gravity. Acceleration, let's just shorten it to acceleration. So we have mass times acceleration. The unit for mass is kilogram, so kg times acceleration is m slash s squared, so equal to kg m slash s squared. Okay, but you know, the one thing you need to know is that there is the SI unit and there is the unit you can generate. The SI unit of force is Newton. So Newton is preferred, Newton. And the symbol is capital N. It means Isaac Newton came up with force. So we have work. Now we say work is done when the application of force moves through a distance. So force times distance. That is work. So we have force to be Newton. Then distance, length, so meter, m. So Newton meter or joule. So things get interesting here. Joule. So it's either Newton meter or joule. Then the final one we'll look at is power. Now, power is work done over time taken. So work done equals work done over or on time taken equal to. So we are saying the SI unit of work is joule. So J over time is what? S. So equals joule per second. But the SI unit of power is what? W-A-T-T. Okay, I was supposed to tell you this. The symbol for joule is capital G. The symbol for power is, the unit for power is watt. So the symbol is capital W.